video that I explained you how to do the calculations and in which kind of situations that we are going to apply that. So I'm going to discuss you some of the calculations using some of the examples, right? Okay, so let's look at the first example here. It says the following are the systolic blood pressures of 13 patients undergoing a drug therapy for hypertension. So you have a sample of 13 where all these values are blood pressure values of 13 patients. So the question is, can we conclude that the median systolic blood pressure is less than 165? So when you are given with this question, so actually for this kind of a question, you can go with a sign test or a Wilcoxon sign rank test, right? Since it's satisfying all the conditions, all the assumptions of both testing procedures. But whenever you can apply the Wilcoxon test, I encourage you to apply that since it's more powerful than the sign test. But in the exam, if you apply any test if both testing procedures are possible, you will get marks. If I have not mentioned any particular test to apply, if you can apply both tests, you will get marks if you have applied one of them. Right, anyway, now when you look at this question, so we need to find out the systolic blood pressure, the median value of the systolic blood pressure of these patients is less than 135 or not, right? So I will first, you have to write down the hypothesis. So I'll take the median value, right? So I'll take M as the median value, median systolic blood pressure. So in that case, I can write my H naught value. So, right, and then I can write the H1 value. So in this case, I will first write the H1 value since we are taking the complaint, right? We are always taking what is asking in our question, right, as our alternative. So I'm going to write the median is mu. We have to find whether it's less than 165. Okay, so that would be our alternative hypothesis. So when you're writing the null hypothesis, you can write it as mu equal to median m equal to 165, or else you can write it as m greater than or equal to 165. So anything as you like, you can write it. Now we have written the hypothesis. So the next thing is, how are we going to calculate the test statistic? Right? How are we going to calculate the test statistic? So we have to test the median value is less than 165. So the given median value is 165. So first what you have to do, you have to take your data set and then you have to subtract 165 from each and every value. So this is your data set. So you have to subtract 165 from each and every data point. So actually in this case, it would be much easier if you just first arrange your data set in ascending order, because then you can just have all the positive ranks in one place and all the negative ranks in one place, right? So if you look at the data set, or else you can just keep the data set as it is and apply, but then you have to just you have to look and find where is the positive differences and where are the negative differences. So it would be much easier if you arrange them nicely in ascending or descending order, right? So if you look at the data set, if you are going to arrange it in ascending order, you can see the minimum value is 114 and the next minimum value is 118. Likewise, you can arrange, and then what you have to do, you have to take the difference between the observation and the given median value, that is 114 minus 165, then 118 minus 165 likewise. Then what you have to do, so when you take the difference between 114 and 165, so that would be a negative difference, that is negative 51, and in this case that is again a negative difference, so that would be negative 47. So what you have to do, you have to take these differences, take the absolute value and rank them, right? Take the absolute value and rank them. Okay, so what you have to do here, so I'll give you some time, take some time and take your data set and take the differences, right, and then take the absolute value of the differences and then rank them. So you can pause the video and take the rankings. Right, so I hope that you have paused the video and you have done your calculations. Now if you look at your alternative hypothesis, so here you have the less than inequality. So in this case, because of you have the less than inequality, our test statistic, that would be W plus, right? This would be W plus, as you have the less than inequality in your data set. So our test statistic is W plus. That is, after doing the rankings, you have to check what is the you have to check the summation of all the positive differences, and that would be your test statistic, right? So I will just show you my calculation table. Right, so here I have arranged all the observations in ascending order, and you can see the differences. In the first one, minus 51, minus 42, minus 21, minus 15, minus 13, likewise. Right, and then I have done the ranks. Right, so you can see when you look at the absolute value of these differences, the minimum value is minus 2, right? So I have to put 1 for that one, and then the next minimum value is plus 7. So when you take the absolute value of minus 7, that would be plus 7, so that would go with the rank 2. And then you have minus 8, so you have to go with rank 3. But when it comes to 13, you have minus 13 here and you have plus 13 here. That is, you have to give 4 and 5 to these two, but you have to take the mean value of the tied values. That is 4 plus 5 divided by 2, that is 4.5. So I have to give 4.5 to this and 4.5 to this. So now you have used 4, 5 both rankings. Then you have 6 the next one. So the next minimum is 14. You have 6 here. The next absolute minimum is 15. So you have 7. The next one is 18. You have 8. The next one is 29. You have 9. Right? And then the next, likewise, you can, I'm sorry, there's a small change here. So there's a small mistake. So when it comes to 21, that would be the next minimum. So that is, here this 10 should be changed to the rank of this one should be changed as 9, and rank of 29 should be changed as 10. Right, so these two are correct. So then you have 47, 11 and 51, 12. Okay, so in this case, when we are interested in the positive ranks, the summation of the positive ranks. So you have to take the total of all these positive ranks. right? So when you take the total, now the 21's rank should be 10. So 20, there's a mistake, 21 mistake in my calculation, 21's rank should be 10. So when you take the total of all these values, that is 4.5 plus 6 plus 8 plus 10. So that is adding up to 28.5. So your test statistic value W is equal to 28.5. Now we have to read the table value. So we didn't get any difference which is equal to 0. So we don't have to omit any observation. So in your sample you have 12 values. Sorry, in our sample we had actually 13 values. So here you can see here we have 165. So that is when you take the difference between 165 minus 165, that would be equal to 0. So we have to omit that observation. That's why we are left with only 12. So you don't have to calculate the difference of 165. So here we have to now we can just take the sample size, that is equal to sample size is equal to 12. So now we have to refer the Wilcoxon table to read the table value. Right? So the sample size would be 12 and we are doing, so you can read 12 here, and we are doing a one-sided test. So we are doing a one-sided test with alpha 0.05. So the corresponding value would be 17. Right, so this would be the corresponding value 17. So from the table value you can read table value is equal to 17. So what is the decision? If the calculated value is less than or equal to the table value, we can reject H0. So in this case actually we can't reject. So we do not have enough evidence to reject H0. Right? We do not have enough evidence to reject H0. So that is, we cannot conclude that the systolic blood pressure is less than 165. So that would be our conclusion. So I hope you are clear with that. Okay. Right, we'll go through with another example and see. Okay, so this one says the following data are IQs of arrested drug abusers who are aged 16 years or older. So we have to use the Wilcoxon sign rank test to determine if there is any evidence that the median IQ of drug abusers in the population is different from 107. So you have a sample of IQ values, right? And these IQ values are obtained from a set of drug abusers. So we need to find out whether this the median value of the IQ is equal to 107, or if there are any difference between or is it different from 107, right? So in this case you can understand we have to test two-sided test, right? Because we want to just check whether the median of the, I'll just take M as the, M is the median IQ level. So in the exam also you have to define all these terms. So we have to just check whether the median IQ level is equal to 107 or not. Is it different from 107 or not? So I'll write H1 as M is not equal to M is not equal to 107, and our null hypothesis is M is equal to 107. So here we have to do a two-sided test, right? So just as before, first you can check. Now our value is 107, whether you have a value which is equal to 107 in your data set. So you can see there is a value which is equal to 107. That is when you calculate the difference, that would be equal to 0. So you can omit this observation and take the rest to do the calculations. Then your sample size would be reduced. You have to reduce it accordingly. So here actually you have 15 observations. So when you omit this, you are left with only 14 observations. So you can just, if you like, you can arrange these values as in ascending or descending order. And like as before, you can just subtract 107 from each and every observation. And then you can observe the differences, take the absolute value of the differences, and then you have to rank them. So what will happen when you take the test statistic here? So here when you take the test statistic, it's a bit different. Since it's a two-sided test, here you have to actually calculate W plus and W minus both. And then you have to calculate the minimum value. So your test statistic would be, you have to calculate the summation of the positive ranks, summation of the ranks of the positive differences and summation of the ranks of the negative differences, and then you have to take the minimum value as your test statistic. So you can pause the video and do the calculations. Right, for time being I'll show you my calculations. Right, so you can see the data set. So the first value is 90 when you arrange it in ascending order. So you have to subtract 107. So that is minus 17. 94 minus 107 minus 13. 99 minus 107 minus 8. Likewise, we have all the differences. And then we can put the ranks. And then we can take the summation of the positive ranks, that is 64.5, summation of the negative ranks 40.5, right? And then when you consider these two, minimum is 40.5. So our test statistic is the minimum, so that is 40.5. Right, and then our sample size is equal to, simple n value is equal to 14, right? Simple n value is equal to 14. So that is, and the alpha value we know, alpha value is equal to 0.05, right? Our alpha value is equal to 0.05, right? So now we can read the table value from the table. So let's look at the table. Okay, so our sample size is, you can see sample size is 14, and then you can take sample size as 14, and then we are doing a two-tailed test. So you can take the two-tailed test columns, and then alpha value is 0.05. So as for that, our table value is 21, right? So you can write down our table value is equal to 21. So what is our decision? So if the calculated value is less than or equal to table value, we can reject. But we can see in this case also the calculated value is 40.5, but the table value is 21. So in this case also we do not have enough evidence to reject H naught. So that is, the conclusion is, we cannot say that the median IQ level is different from 107. So in the exam, when you do the calculations, you have to write down what is your decision as well as what is your conclusion. So the decision is either to reject H0 or to accept H0, but your conclusion is what you by rejecting or by accepting H0, what you are going to conclude. Now in this case, our conclusion is we are going to conclude that the median IQ level of these drug abusers, we cannot say the median level of these drug abusers is different from 107, but actually we can't say it's equal to 107. Only thing we can say is we cannot say it's different from 107, right? Okay, so you have to write down the conclusions as well. Okay, right. So that's how you can apply the one-sided test and the two-sided test using Wilcoxon sign rank test. Okay, so as in the sign test, you have like you can use the large sample approximation also, right? In this case, when you use the large sample approximation, so at the beginning of the Wilcoxon sign rank test, I showed you the probability mass function of this test statistic, right? So in that case, we can calculate the expected value and the variance of this test statistic W. So if you just give a try and see, you will see the expected value is equal to n into n plus 1 over 4, where the variance is n into n plus 1 into 2n plus 1 over 24. So this is the expected value and the variance of the test statistic, right? And in this case, so you don't have to by heart these equations. If you have to use them, I'll be giving the equations in the exam. So if you want to use the large sample approximation, where you have a sample which is greater than 15, right, then you can use the large sample approximation in a Wilcoxon sign rank test, right, where you can convert the data set into a normal distribution. So we know what you have to do is you have to take your test statistics, subtract the mean value. So W minus mean value is this, n into n plus 1 over 4. And we have to divide it by the standard deviation. So if this is the variance value, you have to take the square root. So when you take the square root, this will show you a standard normal distribution. So using that, you can convert it into a standard normal distribution. Okay. So the only problem is now this is exactly where you can use your data set when you have no tied values, right? But if you have tied values in your distribution, for this approximation, you cannot use this equation directly. You have to do an adjustment for the tied values, right? So, but I think I'm going to stop at this point, so you can just go through with the calculations and see. So next time we'll just have a look on the tied values, how to use the large sample approximation when you have tied values. So get ready for that, and you can go through with the questions and you can go through with the sums that we discussed. What you can do is you would read the question, do the sum by yourself, and then you can check for the answer, right? Okay, thank you so much.